Here we're given a polynomial and one of its zeros. We want to find the rest of the real zeros and factor the polynomial. Let's look at how we can use synthetic division since we know one of the zeros. Because we know that -2 is a zero of this polynomial, this zero of -2 corresponds to a factor of x plus 2. So when the zero is -2, the factor that we'll be able to find is going to be x plus 2. So for synthetic division, we're going to take the zero that we know, so the -2, and place it out in front. And then we're going to take just the coefficients from the polynomial. So the coefficients are 1, 2, -3, and -6. So for our process in synthetic division, the leading coefficient just comes down unchanged. And then our process after this is to multiply and then add, multiply and then add. So -2 times 1 is -2. And then we're going to add 2 plus -2 to get 0. Now take the 0 and multiply that times -2 is 0. And then add -3 plus 0 is -3. Multiply -2 times -3 to get +6, and then adding -6 plus 6 is 0. So this number at the end is our remainder. So a remainder of 0 tells us that x plus 2 is a factor of the original polynomial, which we knew since we were told that this was a 0, but this is what's going to allow us then to do some factoring. So these values are telling us the coefficients for our quotient. The first number that comes up next to the remainder is always going to be your constant term. The next number is going to be the coefficient for the x term, and then the next number for the x squared. If we add more terms, we'd just keep increasing in degree from there. So this is telling us that the quotient that has come out from our synthetic division is 1x squared, so just x squared, 0x, so we can leave that off, minus 3. So how do we use this? So if we think of our original function as being the x cubed plus 2x squared minus 3x minus 6, since we started with the 0 of -2, that corresponds to the factor of x plus 2. We've really found that if you take x plus 2 times x squared minus 3, that if you were to FOIL this, that would give you back the original function. So to be able to find the rest of the zeros, we need to find the zeros that go with this quotient x squared minus 3. If you can factor, that's the easiest way to do that. In this case, x squared minus 3 cannot be factored. But we can still think about where we have our zeros by solving when is x squared minus 3 equal to 0. Adding 3, we have x squared equals 3. And if we use our square root property, taking the square root of both sides, the square root of x squared is plus or minus the square root of 3. So that means x is plus or minus the square root of 3. So here's what we have found. The fully factored form for our function, we can write it as x plus 2, the factor that corresponds to the 0 that we were given. We now have x plus the square root of 3 and x minus the square root of 3, plugging in those zeros that we just found. And we can list out our zeros. Our zeros are at x equals -2, x equals negative square root of 3, and x equals positive square root of 3.